What's up, math fans? One of the coolest circles there are is the unit circle. Unit circle. What unit means is means one. So if I take a circle and I put it on a graph with x and y axis, and the center is at the origin, well, one refers to the radius of that circle. So the distance from the center of my circle to any point on the circle, that's the definition of radius, is going to be 1. Whether it's 1 foot, 1 inch, 1 centimeter, that doesn't really matter. If you're on a graph, think about graph paper, one box represents 1 unit. So the radius is 1 unit. So if I ask you for the length of ON, that's the distance from O to N. O is the center, N is on the circle, so that's my radius, and that's 1. What about OP? Well, look at P. Pink, I put it in pink. P for point, not for pink. P is also on the circle. OP is also a radius. If you think about a clock, maybe the minute hand or the second hand on the clock, when it goes around the clock, it doesn't change size, it's still the same size, just like the radius is still the same radius. So OP is also still 1, and that's very, very helpful. Whether I put P in here, which is quadrant 1, whether I put P on this part of the circle in quadrant 2, whether I put it in quadrant 3, or whether I put it in quadrant 4, won't matter because it'll still be 1. And 1 is a very easy number to manipulate in mathematics. You'll see when I get to some examples. Now I'm going to drop a perpendicular line from P straight down to the x-axis. I've already called that point G. And what does perpendicular mean? It means I formed a right angle. Now if you can look carefully, you'll see PGO, that's a right triangle. Now we already established that OP is the hypotenuse and it's 1. So I'm going to put a 1 here. And then you just have to figure out, well, OG is, what is it? I don't know, but you have to understand that it's less than 1, so it's going to be either fraction or decimal. You see how 1 is over here? So if you're on a graph paper and you follow 1, and you're on a graph paper and you follow 1, 0.11 is here, off the circle. So anything on the circle is going to be smaller than 1, 1. I really don't know what it is. I'm going to just call it X for the x-axis, and then if you look at the height, I don't know what that is, so I'm going to call it Y for the y-axis. So really I'm looking at this right triangle here, x, y, and 1. I'm going to put theta here because if you notice P-O-N or P-O-G, either way, created theta, an angle, any angle. And remember, if you saw my video on angles, x-axis is the initial side, coterminal angles to be specific. X-axis is the initial side, and the terminal side opens up counterclockwise, all right? So here, I'm looking at my angle. And again, it could end in quadrant 2 being an obtuse angle, or quadrant 3 or quadrant 4, it doesn't matter. So there's my theta. Now, since it's trigonometry, I just want to explore. So let's see if we can figure out what the sine of theta is. Well, here it's opposite over hypotenuse. Remember SOHCAHTOA? Sine is opposite over hypotenuse. So that's y over 1, and I don't have to write the 1. Cosine theta is adjacent over hypotenuse. That's x over 1, and I don't have to write the 1. Anything over 1 is itself. And I can even go so far as to ask you tangent of theta, which is opposite over adjacent, which is y over x. So these are 3 formulas that are very helpful when you're converting from the geometry mind frame to the trigonometry mind frame. So remember, the x-coordinate is the cosine of theta, and the y-coordinate is the sine of theta. So rather than write the point P as x comma y, most people will write point P as x comma y. We can now rewrite it as cosine comma sine. Cosine theta comma sine theta. All right, that's just the conversion from geometry to trigonometry. Same point, but instead of looking at it as x, y, we look at it as cosine, sine. How is that helpful? When you're trying to determine attributes of an angle, that might help, especially if you have a calculator. So let's look at an example. Here's theta, and I've given you the coordinates as radical 2 over 2, comma radical 2 over 2. And they might ask you, well, what's the sine of theta in this question? All you have to do is remember. You don't have to do any calculations. It's cosine comma sine. My cosine is the x variable, and my sine is the y variable, the y coordinate. So if you're asking for sine, it means you're really looking for the y coordinate. This is x comma y. You're looking for the y coordinate, which is the radical 2 over 2. You can run to the calculator, figure out what the decimal representation is, but that's fine. It's less than 1, so it makes sense. That's fine. What about the cosine? Oh, that's the x coordinate, which happens to also be radical 2 over 2, and that's it. It's as simple as that, all right? You don't have to go crazy. You can also do the tangent for extra credit. Let's look at number 2. Same question. What's the sine and the cosine? So, if I ask you for the sine of theta, that's what? If this is xy, that's the y coordinate, so I might say that the sine of theta is 0.8777. Usually it's safe to have a decimal to 4 decimal places. And what's the cosine of theta? That's the x coordinate, which is 1/2. And we're done again. Until you learn how to actually find an angle. Let's say they ask you for the missing angle. Well, I'm sure you've seen my geometry videos on finding a missing angle when you had the sine and cosine. So what I could do is pick my favorite one, and I don't need both. I'll pick the cosine. Cosine theta equals 1/2. Do you know how to find theta? You go to cosine inverse. This is like a -1 here of 1/2, which is also known as 1 divided by 2. So I'm typing this in my calculator, graphing or scientific. Cosine inverse 1 divided by 2, and it'll give you the angle that has a cosine of 1/2. That should give you 60 degrees. A couple things you want to make sure is you press second or shift in order to get this button. Also, you want to make sure you're in degrees, not radians, because you're looking for the degrees. So look at that. The coordinates is enough information to find the measure of the angle. So no matter where that point P hits, if it hit up here, it'd be a bigger angle. You'd be able to use the coordinates to figure out the angle. One more. Now they've given you the angle, could you find the coordinates? You should pause it and think about this one. Come back to me. So if you know the angle, then you should now know that the sine of 30 is what? Let's see here. Sine is equal to the y coordinate, and then the cosine is equal to the x coordinate. So then you just go to your calculator, you type cosine 30, you press enter. You're going to get, I'm not sure. I think you're going to get 0.87777. All right, it's right here. Check my math, 0.8777. And then when you press sine 30, you're going to get 1/2 or 0.5. So, and check my math, please. So if they ask you here, what are the coordinates of point P? Point P is going to be 0.8777, 0.5. And it's as simple as that. So you can go forwards with the point, get the angle, or you can go backwards with the angle and get the point. Thanks for watching. Get the point? See ya.